Our keynote speaker for this morning is Mr. Anku Jain. A brief introduction before I invite him onto the stage. Anku Jain is presently the Managing Director of MediaTek India. He's heading MediaTek's pan-India operations with offices in Noida, Bangalore and Mumbai. He's also responsible for heading multiple R&D business units in Noida, in addition to Indian government relations. MediaTek Inc. is a leading Taiwan-based global fabless semiconductor company that powers more than 1.5 billion devices a year and is a leader in developing innovative systems on chip for mobile device, home entertainment, connectivity, and IoT products. Ladies and gentlemen, please extend a warm welcome to Anku Jain.
Thanks for that introduction. I think he said many things which I was supposed to say. So I hope the coffee shot helped you to wake up and ready for this talk. My name is Anku Jain, and I'm the Managing Director of MediaTek in India. MediaTek is a global fabless semiconductor company, and with various offices worldwide. And we also have some offices in India. One is Bangalore, R&D center, and we have an office in Noida, and also we have a small office in Mumbai. So let me start my presentation. So we are the fourth largest fabless company in the world, IC design company in the world, and we ship about 1.5 billion chips per year. So that's a very huge number, and it shows the kind of penetration we have in various devices. And we are actually 20% around you. So many of you may be using devices or something like TV or smartphone or a VAD. Which could be at your home, but maybe you don't realize that it's having 20% of your homes would have MediaTek chip inside. And also, it's about 1 in 3 phones worldwide are powered by MediaTek, smartphones and feature phones. So that's a very great number. And these are the various verticals we are working in right now. We have leading market position due to the synergy between the different devices. So we are number 1 in Android tablet. We are number 2 in smartphones. And we are number 1 in voice assistant devices. For example, the Amazon Echo Dot uses a MediaTek chip inside. And we are also number 1 in connectivity network. Number 1 in digital TV. I think we have a very majority market share in smart TVs. And also number 1 in optical drives and Blu-ray drives. And finally, also number 1 in feature phones. So you can see that in the various verticals that MediaTek is in right now, we have very leading position in these verticals. And this is our mission, our vision, that we want to enhance and enrich everyone's life. So the motto that MediaTek wants to follow is that we want to make great technology available at affordable prices, so that we can have more penetration of for example, smartphones should be able to be available for the masses. And that's how we can see the adoption of smartphones going up so heavily in the last several years, including in India. And I think MediaTek has played a big role in that. And it's somewhat, we can say that MediaTek has played a role in the digital India revolution. And also, there's something we call everyday genius, which means that we feel that every person has something amazing in him, and he's capable of doing something amazing, and that's what we call everyday genius. And today my topic actually is about artificial intelligence. I think we have talked a lot about in the last 2 days about this, and we had very good speeches on this topic. But I will maybe go back to a bit basics of AI and how did it evolve in the last several years. And first, I'd like to ask a question. How many of you think that you are actually using AI in your daily life? Okay, so that's good awareness. And I think I could see 20% people raise their hands. And by the end of the presentation, probably more people will raise your hand, because many of you don't realize that you are actually using AI in your daily life. So what is AI? So AI, you can see several different words, like artificial intelligence, deep learning, neural networks, cognitive learning, classification, predication, data analytics, and so on. So there are many different ways of looking at AI. And these are the various words you can see from time to time. And this is something which has, although actually it's been there for a long time, but it has caught on in the last 1 decade or so. So let me go to a very long time ago, over 100 years ago. So this is a device. It is actually an electromechanical device, and they used to call it artificial calculation at that time. So still, they used to use the word artificial even 100 years ago. And this device is something which has no electronics inside. It is just electromechanical, and it is very tedious. It uses punch cards and so on, and it can still do some kind of calculations, computations. So this is something which was 100 years ago. And then we had, Mr. Alan Turing. He's supposed to be the father of theory of computation, and he brought on the concept of abstract machines which can solve anything, any computation. So this is about Alan Turing, and he had a Turing machine which was supposed to be a solution for everything, and finally this is a slide on the storage. So you can see in 1950s, a 5 megabyte hard disk. Well, this is the device you can see. It used to weigh 1 ton. So 1 ton of a huge device was able to just store 5 MB of hard disk of storage, and used to, I think, cost about $35,000 US. So this is what you can see, how far we have come in the last several years. And why I have talked about these three things. One is about the storage, and then before this about the algorithm, because he was able to talk about algorithms, and before that about the calculation. So these are the three topics which are inherent part of AI. For AI, we need more computation power, we need more data, and we need very solid algorithms. And that is what has changed in the last decade or so. So this is the evolution. So actually, AI is a word, it was coined a long time ago, in 1950s. So at that time, it was still a very theoretical concept, and that was not the right time for it to take off. And then there's something called machine learning, which came up in 1980s or so. And in the last decade, after 2010, is something, what has evolved is deep learning. It was also there earlier, but it has actually been able to be implemented and executed. And this is, I think you may be aware. So do you think AI can beat humans? So we have seen two examples in the last 20 years. Garry Kasparov versus Deep Blue from IBM in 1997. So this is where the machine won. And the more amazing was in 2016, using deep learning, the AlphaGo machine was able to beat the best player of the game, who was Lee Sedol. And this was actually a turning, this really changed the mindset of people, because earlier it was felt that it's not possible. And then this happened, and this really shows the amazing power of the AI. So, I think the past speakers yesterday had talked about the market potential. We can see that in the next several years, the market potential is very huge. We can reach up to $127 billion by 2025. So that's a huge potential for all the businesses. And you can see this is some articles from the last 1 month I saw in the newspapers. You can see even in India, we can see a lot of attraction for AI talent. AI salaries heading Harvard, data scientists, and so on. So you can see many such articles recently, especially in the last 1 or 2 months I've seen. So this shows that the real work is happening in this topic, also in India. And this is, later I'll talk more about smartphones. How does AI work on the edge and on the smart devices? But it's also, AI is prevalent in various other fields, like software and IT and retail and so on. So there are many different verticals where businesses can use AI to enhance their productivity. Okay, so this slide, I think if you see this slide, then you will realize that maybe most of you are using AI already. So a Google service like Google Maps, that's actually based on AI, because it's self-learning and able to improve the directions and the time taken and so on. Then Amazon Echo is also based on AI. It's about voice input. Autonomous car to some extent, like you have the automatic parking in some cars, smart surveillance, and Apple Siri, chatbot. This Pepper is a robot which is able to detect your emotions, whether you're happy or angry, and take some actions. And then as Asus Zenbo is another, it's a entertainment robot, and UAVs and smart glasses. So there are many instances of AI, which is, I think many of you I'm sure would be using it already. Okay, this is a slide I made for what's the difference between machine learning and deep learning. So I think these two sometimes, if you are just getting into this field, you may wonder, what's the difference, and because both are things are used at the same time. So machine learning on the top, the input is once the input is given to the algorithm, actually the intelligence is all rule based. It is hand coded. For example, if you want to identify a cat, you have to feed that the cat has 2 ears and 2 eyes and a certain shape. So that's all rule-based. So this is machine learning. So based on those rules, the computer can identify whether it's a certain cat or dog or something like that. So that's the output. So, but this is very tedious because for everything, you need to have a very specific way to make it learn. But now that has been taken up, the next stage is deep learning, which is the input, once it's given, the model is created, which is trainable. And the more data you give to it, it is able to learn itself. So, and using deep learning concepts. So this is more feasible, and that's why we can see, and these algorithms have been developed in the last 1 decade or so. Okay, this is a neural network concept. So on the left side, you can see biological neuron. I don't know about me, but normally a human brain has 100 billion neurons. So that's a lot, right? So if you see a neuron on the left side, there are some inputs, and then there's some output. So based on the inputs, the neuron is able to decide and maybe get fired and create an output, maybe 0 or 1 kind of thing. And then that output is given to the next layer, and because there are 100 billion of neurons, so it's the next layer and so on. And finally, the decision is made by us. So on the same concept, there is something called artificial neuron. And on the next slide, I can. So this is the artificial neuron in which the inputs is taken from the data, and then that is given to the hidden layers, and then the output is formed. So in this artificial neuron, you can see there are several inputs, and there is a activation function, and there's output. And then these several layers can actually make a decision, almost like a human intelligence. But for that to happen, first the model has to be trained. And this is some brief history of deep learning. Why has it shot up in the last 10 years? So in 98, so one basic ingredient of deep learning is data. You have to have very good data which can be used to train the model. So in 98, there was AliNet was able to develop a neural network using 3 convolution neural networks and 2 fully connected layers. So this was able to detect the digits very accurately. So in fact, some banks were able to use these models to read the checkbook, check the digits in the check. It was actually being used. But what was the turning point was 2012. So that's a very special year because that's a time when certain universities in the US and also I think Google, etc. They released the ImageNet. So that was tens of millions of pictures, which was made available in the open domain. And then there was a contest, and in which LXNet neural network was able to achieve amazing accuracy. And that's when it was, we can say it was a very special year, 2012, where it really took off. And I already mentioned about this. These are the 3 ingredients for AI to work. We have big data, so that's very available, as we heard a lot of speakers yesterday as well. And algorithms are getting better and better to train the model and also infer from the model, and also affordable hardware and computing power. And this is what I'll talk about 3 different ways in which deep learning has helped in 3 different topics. One is about image recognition. How has the accuracy improved in the last several years? So the error rate very recently was 26.1%, and which has now gone down to 3.57%. So that's a huge improvement. So if you give an image to a human, actually the error is 5%. So actually the computer can, or the AI can actually detect the image more accurately than humans. That's the status right now, because the error rate is lower than human. And also speech recognition. So speech recognition also is, the test was done using the switchboard data set. That's a very old data set which was made on the using some phone conversations. And then we have seen how the accuracy have increased in the last few years. Again, you can see using the deep learning, since 2010, the accuracy has improved a lot by several leaps. And now the accuracy is 6.54% of speech recognition. So that's really a huge change. And all this, I'm talking about 8 years or 10 years. So it's really recent, the changes which have happened. And finally, one more example of self-driving vision ADAS. So this is also, the object detection accuracy has increased. And as we saw earlier, the accidents is the real thing which we have to avoid. And in 1.5 million miles, there was only one accident. So that is, again, a very accurate result. Okay, this is another way that, again, I think maybe I can skip this, but on the right side, you can see I talk about computing power. So these kind of AI inferences it needs a lot of computing power, right? For the vision perception, for example, it needs lower computing power as compared to vision quality. So for vision quality, the computing power required is huge if we go up the ladder chain. And the computation requirement is measured in something called max, because when you infer from a model, the main calculations are multiplications and additions. So that's why it's called Gmax is giga multiply accumulations per second. So that's the main measure of to assess the AI benchmark performance. So you can see that on the top there, the vision quality needs 200 G of performance. Okay, this is, maybe I can. Okay, on the left, we can see the training. There are two steps to AI. Maybe I'll just go through it in 10 seconds. On the left is how to train the AI model, and the right side is inference. So once you train the model, which happens on the cloud, the inference can be done either in the cloud or on the device. So what MediaTek has done is, it's called Edge AI, that the inference can actually be done on the device itself. That saves a lot of power and time and so on. And these are some challenges for Edge AI. So about computing capabilities, of course, it has to get better and better. Thermal constraints, because on a small device, that's always a challenge. One has to take care of that. And power consumptions and bandwidth. So there are certain challenges which the AI has to take care of on the device. Okay, now I will introduce something called MediaTek Neuro Pilot. So this is an open and flexible platform. Maybe this is not working. It's a flexible and open platform, which is a combination of software and hardware. So the software part of it provides the app developer a very solid way of developing applications, of AI applications. And also it supports heterogeneous AI computing, which I'll mention later. And it also has a hardware component, which is the APU, the AI processing unit. And this is some detail about how it, the various layers, which is more relevant for the application developer. So he can actually use the SDK, NeuroPilot SDK, to write applications, and that can leverage the computing capability of the MediaTek platform. As I mentioned earlier, it has heterogeneous computing. So the developer does not have to care about whether the certain application has to run on CPU, GPU, or APU. The platform itself takes care of it, based on the parallelism in the calculation. And these are the various CPU, GPU, and APU can be used, and depending on the application or the requirement, the right processing unit is used. Okay, so this is okay. On the next slide, this is actually an event IESA had held a few weeks ago. It's called Megathon, and we had invited a lot of developers. IESA had actually invited a lot of developers to create applications. So some of them actually also use the NeuroPilot, and they have some testimonials which I can share here.
Hello everyone, I am Anil from Wareberry. NeuroPilot is the most advanced architecture, and it is more compatible with any chipset and it is powered with lot of architecture, and engine is more flexible, can use different algos and machine learning algos or AI algos, which is easy to adopt any product delivery company.
I'm Alex Vishwa from Cura India Private Limited. I'm a developer over there and I work on IoT technology. Recently we have been working on IoT motor controllers, and now I have taken this chance to work on MediaTek Neuro Pilot.
Hello, I am Nipun Sachdeva. Platform is really great. We are getting all the libraries which can be utilized for doing all the computations related to your facial expressions. If you talk about the gestures, if you talk about counting the number of people, so that's what we are doing with that one.
I am Ashish Kumar.
Okay, so yeah, maybe I can move on. Okay, and what is the edge AI development trend these days? So let me talk about in a few slides. So as MediaTek, we are actually an edge AI enabler. So as I mentioned in the first few slides, we are into various verticals. And many of those verticals, actually you need to have edge AI. So our basic main base platform is able to support edge AI on smartphones, digital TV, routers, smart devices, and etc. And we have a very competitive AI engine, plus complementary IPs. We have cross-product lines, write once, and use in various different devices. So that's really very efficient. And the Neuro platform is ecosystem enabler. So that's a key point, that we want to have use Neuro Pilot and enable the application developer community or the ecosystem to let the product, the innovation get unleashed. We provide the platform, and the developer community can actually use their innovation as they like. Okay, and this is some more examples of how does the various AI examples work on the device. So we can see a single camera Face ID, and smart album, face beauty, voice assistant, smart camera, video chat, and targeting certain applications. So there are some examples of the AI on the device, and I feel that AI is just getting started. It's a very nascent stage, and MediaTek really believes that AI is the next frontier for device innovation. So we are putting a lot of efforts to keep improving the capability of our AI engines. And this is some more examples of how AI can be used on the device. So in the center, you can see a few children playing. And actually, the AI camera, you can instruct the camera to only track your own child. So the game is happening, and the camera is able to just focus on the child. And on the right side, you can say that I just want to track player number 13, for example. So this is certain applications which can happen, right? And also in CES last month, we have announced the new AI enhancements for smart TVs, displays, and cameras and speakers. So this is, is really AI is getting enabled in various verticals. Okay, so now I have some demos of AI. How does it really work? How do you feel? So first, on the first slide, I have some demos which are based on P60 and P70 platforms of MediaTek. So last year, 2018 was a really good year for MediaTek. We were able to release P60 chip, P70, and a few others. So these were accepted quite well in the market, and the end users are quite happy. And in the next slide, I'll show about the P90 chip, which was released in December 13 last year. So these demos, I'll just go through them, very short demos. So in this demo, you can see that the phone is able to have multiple recognition of different objects. So you can see bottle and multiple, banana and so on. So this is, again, this is just an example of the capability of the platform, right? And the developer community has to use this to create any application they want. This is about some filters on the face of the person, and he's using different filters to make some changes. And this is a very important feature, which is about noise reduction in a conversation. So as you know, if the bandwidth of, let's say you're doing FaceTime or a video call, if the bandwidth is low, then if on the left side you can see it's very clear, and on the right side the face was not so clear. That's because the AI is able to detect the face part of it. So that is actually transferred more, better way, and the background can be ignored. So this can actually help in better transmission of a video call. And this is also about P70 chip. It is human pose recognition, 2D human pose recognition. So there are 14 points which the camera can detect, and the movement of the person can be easily mapped. So this, again, can be used by the ecosystem players to make things like, let's say, yoga. If a person is doing yoga, or let's say playing a game of golf, the phone can actually see the pose and help you to improve your game, because it can tell you that you are doing this wrong or that wrong. So that is a kind of innovation that can happen. And this is about P90 chip, which was launched just 2 months ago, and this will be shipped in phones very soon, in the next 1 or 2 months. And so this is, let me go through a few examples here. So this is a 3D avatar. I just picked up the demos from that launch in China. So this is the lady, and you can see the avatar is doing the same thing. So this is a 3D human pose recognition. And this is about fast shot with AI noise reduction. So when a person is moving, the camera has to have very fast shutter speed. So along with that, this is also having good AI noise reduction capability. So you can see the pictures are very clear. And this is about the powerful APU 2.0. Again, it has the camera is able to detect the person and do the coloring in a more efficient way for the person. And finally, this is a very interesting thing. You can see that the robots are able to emulate the person in real time. So when the person, he moves his hand, the robots are moving it as well. And the person is being shot by the camera. So this is, actually, I also had done this demo myself on me, but my team thought this is a better model, so they included this. Okay, so this is all I had to say. Now I'll leave you with a video. It's called "This Chip Changes Everything." So the philosophy MediaTek follows is that, as I already mentioned, it's about everyday genius. So we want to enable all the people to do something amazing, and I think they are capable of that. So this and that capability comes from the small chip. So this is what this video talks about. This chip changes everything. It is enabling a lot of devices, a lot of applications, and for the masses. So, and that's something we are really proud about. Let me go through the video, just a very short video.
We all have big dreams. And many of us want to change the world. But how many people actually realize their dreams? At MediaTek, we believe in the power of big dreams. Because we know the biggest chance to change the world always begins with the smallest of details. From the first sound you hear, to the very first glance you take, to each and every beat of the rhythm your heart makes. From your most basic needs to your truest desires, to every decision that is ever required. From your deepest resolve to your highest aspirations. To every crazy idea from your imagination. Starting from the smallest chip to create bigger and better dreams, MediaTek continues to innovate to create even more possibilities for you. Is changing the world really that difficult? With a global network of connections. You already are, and will continue changing this world. MediaTek, this chip changes everything.
Okay, so that's the end of the presentation. So if anyone has any questions, please, I don't know if we have time or not. So any questions? Okay, I guess not. All right, thank you.
I'd like to thank Mr. Anku Jain. I'd like to request KK Giri, IESA Executive, to present a small token of our appreciation to Mr. Anku Jain. On behalf of IESA, once again, we'd like to take this opportunity to thank Mr. Anku Jain for that keynote address.